It's 2019, it's Halloween, or as we would say locally, Hop to Nay. Different name, same type of festival. And Poundland has its stock in, and I thought I'd take a look at some of the items ranging from this motion activated witch, the string lights, this magic one that looks like a large turd and has light and sound, and this strobe light, all of which has particularly interesting features. Okay, let's start with the witch. So this witch has that really annoying circuit in it that makes this noise. And it has a strange colour LED in it. And it's got a motion sensor hole, but there's no motion sensor. I mean, it describes it as a motion sensor witch, but I left it running quite some time until I got sick of the noise and then decided to give up. I don't think there is a motion sensor in this at all. Let's spudge it open and see what's inside. Okay. Here is the module. I bet the same module is used between different units. So we've got a LED in here. We've got, unusually, they've got one big battery and two small batteries just to make up the space. That's quite odd. There is no light sensor hole. Let's take the circuit board out of it. We'll just whip it out and we'll see what we can see. It's the usual thing, it's got the blob on board. Here is the battery holder. Oh, have I just, yeah, I've just ripped it off the battery holder. Was that just folded over? Oh, that's interesting. So yeah, there's the LED, there's a switch, there's no light sensor, it's just pure the sound chip. The LED and the speaker, that's a bit odd. The LED is quite odd because, well, let's try and get these things fed back through and folded back again. I shall try and fold that down. Is that going to make a connection? Oh, was it this? No, it wasn't the screws that held that in. Is this going to work? One moment, please. I'll just squeeze the connections. The LED is odd. It doesn't make any sound anymore. I've broken something. That's all right. I'm not too bothered. The LED almost looks like it has multiple chips in it with different colours. That's strange, but it's not doing anything fancy. Oh, it says RGB. Is that red, green and blue chips in one LED? I'll take a look at that later on. Let's move on. Now I've kind of broken the witch. Not that the witch was particularly good in the first place. It's got an odd construction. The hands are clipped in, the head goes on. It's all very interesting construction. Okay. Over goes the witch out the way. Let's take a look at these LED lights. They do a selection of the LED lights, 20 lights. In this case it's purple, but they also do green, red and orange. And the red and orange are both phosphor based. I think this one's phosphor based, but it's really, whereas when you look at these side emitting LEDs, you'd normally expect to see a little touch of the phosphor. I don't actually see that in these. But the colour spectrum out of them is so rich. I'm just going to, let's power them up. Let's stick some batteries in. The purple is the one that always seems to sell out fastest because it is this amazing psychedelic purple. That is great. It's not just the ultraviolet ones. There must be phosphor in that. Let me ill-advisedly look down the end of one of the magnifying glass. It's showing distinct two colours here, red and blue. I think the chip does have phosphor on it, but it's very hard to say. Very hard to say in that. I think there is a layer of phosphor over a blue chip, red phosphor, but it doesn't look particularly phosphory. That's strange. But these lights are very good. The other advantage of the orange with the phosphor is it's a nice sort of soft pastel orangey colour. And the batteries last for absolute ages with it. Likewise, the red is phosphor. They're good LEDs. I like those sets of LEDs. Let's move on to the magic wand. I was going to say Harry Potter's magic wand, but they're very careful not to say Harry Potter in Poundland because obviously that would be a franchise and therefore extra cost. This is huge. It's not like the usual little mini wand you get. It's really thick and chunky and ribbed and knobbly. It's a bit weird. It does look like a turd with an LED in the end. It's described as wand with light and sound. here's the light. It's right up there at the end. It's a white light, which is what magic actually looks like. And the only sound you're going to get, I've looked up the end with a flashlight. There's no speaker in there. I've not explored any closer than that. But when you click the button, that's it. That's the only sound you're going to get. Unless you shout Maximus Orgasmus while you're actually using it. You're a wizard, Harry. So yes, let's open Harry Potter's big brown magic knobbler and see if there is anything inside other than just a switch and an LED. So a couple of batteries there. The batteries are now out. One has just disappeared. It has appeared again. Now, is this held together with screws? I don't think so. I think it must just be clipped or held together with pins. Where is my spudger? What have I done with the spudger? I've misplaced the spudger. I shall... Yeah, I really have misplaced the spudger. Oh, there it is. Let's spudge this big brown turd. It is held together by little plastic clip pins. And it does look suspiciously like it's the two batteries, it's a switch, and the LED at the end, so it's not got sound effects. Very strange. It's strange that it's just so big, and the colour choice, it's very odd. But then it's so big, I think that Harry Potter would probably have to slip it up his big wizard sleeve when he wanted to put it away. Let's move on to the strobe light. They've done the strobe light before. The last one of these I took apart had a couple of transistors, a little flip-floppy type circuit, and it'll be interesting to see if it's changed. Someone mentioned they'd got one and it was based on a chip. I'm intrigued. Is it going to be a 555? Let's pop the batteries into it. Noting that there's no screw to hold the battery compartment shut, which is good. What about the Harry Potter's magic wand thing here? Does that hold itself shut or does it? Oh, it does click shut. It's got a screw, but it does seem to click shut. That's good. What about this then? Let's turn it on. It is on. Oh, right, okay. So it's blue again, like the previous years. If you turn it right down to the minimum, that's quite slow. Strobe warning, although it's not that bright, to be honest. It really isn't that bright. Let's turn it up. Not much of an effect. Oh, there it goes. It's starting to get fast. That's most of the turn. I'm turning it very slowly. And it's suddenly accelerating. And then it goes a bit intermittent and it just locks up. It jams at the end, either on or off. Okay. That's not terribly smooth. Right, let's open it up and see what circuitry is inside. So I'll just pop these batteries out. If it's the same as last time, there was a screw under here, which there is. And there was also a screw actually under one of the battery terminals. And if I recall last time, I just popped that out because I don't think it was actually attached to anything. Oh, it might be attached to something this time. Oh no, it's sliding up. So you can... Oh, that was bent, I think. Not to worry. It's unbent now. So let's unscrew this. There is a chip. There's not much else other than the chip. There's the potentiometer. The chip, I don't think that's... No, the pinout isn't the correct for... In fact, all the pins are commoned. Oh, pin 1 and 4 are commed together, which suggests a microcontroller. And they've clumped the pins together. I'm just going to see if there's a number on it. No number on it. It's mystery 8-pin chip. Right, give me a second. I don't think it's going to take much to reverse engineer this. In fact, tell you what, let's take a closer look at it and then I shall reverse engineer it. So I shall just focus down it like that. We'll take the exposure off just to brighten that up. What I'm seeing here so far is the switch here. Let's get rid of that screw. The chip, there's one capacitor which is going from the positive connection, which have they used black for the positive? They have used black for the positive. So the positive connection is going to the potentiometer, it's going to the capacitor. The negative connection, which they've used red for, really, is going to the other side of the capacitor and to the chip. That's it, the potentiometer. Right, tell you what, I'm going to reverse engineer this and then we'll take a look at it. This is a very oversimplistic circuit. It doesn't completely make sense. We've got the batteries here, which is 3 AA's. We've got the switch. We've got a typical decoupling capacitor on the circuit board, which is here. And we've got the microcontroller. And normally I would expect, there's a couple of ways of doing this. You could have had an analog to digital converter in the microcontroller, and this is the plus rail 4.5 volts. If the batteries are fully charged, this is the 0 volt rail. You could have had that potentiometer connected between plus volts and 0 volts, but it's not. This isn't connected to anything. And if you'd done that, it would have varied between each supply rail. And if you had an analog to digital converter, it would give you a nice sort of roughly 0 to 255 steps as you turn the knob. It's not. It's just floating at the end here, which means that all that happens in that pin is the resistance changes. And that doesn't, unless they're relying on a input impedance, I'm not really sure. That's very strange to actually act as a voltage divider. The other thing they could have done is that if you have an input pin and you connect a capacitor to the 0 volt rail, then the input pin can be switched to a output state turned low, so it discharges that capacitor, and then it can be switched to an input state and monitored until this resistor charges that capacitor up again. You can implement basically a simple sort of timing circuit external to the microcontroller using that, just by discharging that resistor, that capacitor, and measuring how long it takes to charge up. But they're not doing that. It's very strange. They've also done a bit of a naughty thing. They've commoned 4 of the outputs of the microcontroller. If this is the microcontroller here, 1, 2, 3, 4, 5, 6, 7, 8. They've got those common together as positive. The input is coming in from the potentiometer, which is odd. They've got this one as the negative, and then they've commoned this one with these 3. So you've got 4 pins commoned just to increase the drive current for the LEDs. It's not working terribly well because it's not bright. It's really not bright at all. I should turn it on. Then it'll be even brighter. Yeah, it's very strange. The potentiometer is also 1 megohm. It's a shame that, because if it had been a lower value, it would have lended itself well to modifying. I should have done that on shot, shouldn't I? It would have lended itself well to using the potentiometer to control the intensity of the LEDs if you wanted to use it as a little light instead. So what I'm going to do here, experimentally, let's zoom out. You can probably hear the solder iron running in the background. Let's get this notepad out of the way. Let's brighten the image up a little tad. Lock it off. What I'm going to do here, I'm going to desolder these connections. Now note that positive is negative, negative is positive. That's quite odd. But what I'm going to do here is the positive, which they got as black, is going to one end of the LEDs. I was hoping to change these to warm white LEDs, but I don't have any in the focused style. I'm not sure why. I thought I did have some. I could not find them anywhere. And I'm just going to show how you can adapt this and turn it into a little kind of work light or theming light. So if I desolder that connection, and let's just desolder it from there, because quite frankly, the circuit board is not going to be used after this. And this lead that's going to the LEDs that would have been switched through the microcontroller, the chunky microcontroller, is now going to go onto that battery pin via a 10 ohm resistor. All this is going to do is make a nice little sort of aimable light. So I'm going to keep the blue LEDs in. So let's tin the lead of this resistor. Let's flow it onto that battery terminal there. Then I'm going to crop the other end of the resistor. It's a 10 ohm resistor. I'm going to tin it. I'm going to tin this lead as well. It's already got solder on it, but it's that cursed lead-free solder which doesn't stick to anything. That's going to cause controversy, as usual. And I'm going to connect that onto the resistor. So now we've got LEDs, a switch, we've got a 10 ohm resistor in line with the parallel cluster of LEDs. If these were all warm white LEDs, it would be a little warm white floodlight, but in this instance, it's just, well, that's actually a lot brighter now. It's just a little aimable light. It's not going to strobe anymore because the strobing is actually quite an annoying feature. And if you want to go on a step further, you could rip the back off this circuit board. It's got the hot melt glue in the back, which I suppose I could use the trick for loosening it off with this sort of alcohol, the isopropyl alcohol. Yeah, I'm tempted to do that. Well, no, I won't, because if I pause this camera, it's going to be quirky, isn't it? But if you took the circuit board out, you could desolder the wires off it momentarily. You could desolder all the LEDs. You could solder on the colour of your choice. It could be green, it could be warm white, it could be cold white. And then you can convert this into just a fixed static light like this, which I think it's actually quite a nice thing to do with it. I mean, others may disagree, but to me it makes a nice angleable light for just adding extra sort of splashes of static light in an area without that strobing effect. And also the battery's going to last a very long time because it is decent AA's. It's a nice housing. The circuitry is a bit shady in that. I'm not sure why they implemented it that way, but they have. Oh, the witch. The Wicked Witch. Ding dong, the Wicked Witch really is dead. The LED that had the strange colour was actually a high-speed red, green, blue flashing LED, the one that goes red, green, blue, sun, magenta, yep, and it just goes through those colours and then flashes through them. Really annoying normally. But in this case, because they were flashing on and off, it was resetting. It was just basically showing its first colour, which was apparently white, all the chips on together. I did try unsoldering it after I'd used my meter across it and continuity test just to see what it did, and it did its colour changing sequence. I tried to unsolder it and the whole LED just basically melted. The reason the speaker stopped going is because there's a tiny little circuit board on the speaker with copper in the top just for the two connections for the wires. And at the point when I was taking it apart, it obviously pulled one of those wires and it just rips the copper right off that circuit board. It's not bonded on terribly well, and that just breaks the little copper wires, which would be repairable if you really had an incentive to repair them. But it's not that great. Very strange. So disappointing that the Witch doesn't have the motion sensor, because that would have been quite interesting. Disappointed this doesn't have the sound effect. In the past, they've tended to make a sort of whoosh noise when you push the button, just like real Magic ones. But well, I'm going to rip the batteries out it. That's the only thing I'm going to keep off those. I would say the winner here is, once again, it's the strings of the lights. The Magic one has potential as a prop, and this has potential to be hacked, as I think this was only about £2, and turned into a little work light, or a sort of, I'm just going to point at the wall and see, it puts out a decent splash of light, and even with just the blue LEDs, it actually looks pretty good. So it could be used as a sort of ambient theming light, just to add a splash of colour into an area of your house or in the garden. So it's not bad just for the components, the housing, the battery holder, and the sort of reflector and things like that. It's a good starting base for a personal sort of lighting project. So that's quite a few of the Poundland items. There was another one. It was a mask with the... Have you seen the masks that have the crisscross of the sort of electroluminescent material round the face and across the eyes and in the sort of teeth area? Poundland was doing one, but it was actually LEDs with side glow fibre optic. You know that sort of... this sort of stuff that when you fire an LED up the end of it, it sort of glows linearly along its length. You get mixed sort of qualities of them. But the Poundland one had multiple sections of that with multiple LEDs, and it wasn't too bad at all. It looked very good. It looked so good that they've all gone. You know, you can tell what's best at Poundland because the stock just gets cleared off the shelves very quickly. But there we go. There are a few items, the Witch less so, the Wand medium, but these two pretty good. I think they're really worth getting.